Fantastic talk, Dr. Scafetta. Oftentimes with a name like James Taylor, people ask me whether I will sing for them. Until and unless I have enough beers and cigars in me, the answer is usually no. But I have an even better treat for us this morning. We have our own singing and dancing climate scientist who cleverly realized during yesterday's luncheon debate that to give him the extra edge over Roy Spencer, he utilized not only climate science but also the performing arts to his advantage. Dr. Scott Denning, however, is a serious climate scientist and a very impressive one at that. Dr. Denning is a professor of atmospheric science at Colorado State University. He is also an editor for the Journal of Climate and a project scientist for the NASA Carbon Cycle Initiative. Dr. Denning is also very frequently published in the peer-reviewed scientific literature regarding carbon dioxide topics. Dr. Denning.
Thank you. Thanks very much. Again, I really appreciate the organizers for inviting me and for letting me come here to speak. I have to say, I find this business about the planets and the sun very interesting. I'm an amateur astronomer. I've been fascinated by that stuff all my life. I believe, as I think my co-panelists here do, that the sun's energy is the primary source of the energy in the climate system, that heat warms things up and lack of heat cools things off. I'm a big believer in cause and effect. So I'll tell you what I'm going to say here, and I suspect some of you won't like it, but that's why you invite me. First of all, everybody in this room understands how climate works well enough. Arguing about the details is just not worth your time. Secondly, climate is going to change a lot in the next generation, and policy will be enacted according to people's perceived needs and desires around that change. It won't necessarily be policy that I like. It almost certainly won't be policy that you like, but it's going to happen anyway. My belief is that the political right has been missing, has been absent without leave in proposing meaningful solutions, effective solutions, to what is really not a U.S. problem. It's going to be a problem for everybody. The solutions are going to have to address a whole world, not just a state or a city or a nation. In fact, the world needs you. The world needs Heartland, the world needs heritage, the world needs American enterprise, the world needs the political right to propose realistic solutions. Otherwise, the solutions we're going to get are going to be unacceptable solutions and ineffective solutions. So it's tough to argue with this stuff, right? I mean, ever wonder why the day is warmer than the night, the summer's warmer than the winter, Miami's warmer than Minneapolis? You know why that is. You don't have to argue the details. You don't need a graph. You don't need a PhD. You know that heat in minus heat out gives you a change in temperature. There's just no two ways about it. It's consistent with everybody's experience. You don't want to be on the side that argues against this. So here's some simple facts for you. See if you agree with these. Today is Friday on this side of the date line. I know we had some people here from New Zealand. For them, it may not be true, so I put in the caveat. I don't think you're going to disagree with this one. Billions of people need more energy to lift themselves out of abject poverty. This is true. This is a fact. There are a whole lot more people in this world that don't have lights on than the people in the United States. Burning coal, oil, and gas produces CO2. Again, I don't think you can disagree with this any more than you can disagree that it's Friday. CO2 emits heat. This is a measurement. This has been known for 150 years. Al Gore didn't invent this. Anybody can make the measurement. Anybody will get precisely the same result. And heat warms things up. Okay, all five of these things are true. And it doesn't really matter what you think. They're true anyway. There is nobody in this room who's going to dispute any of these five statements. So let's talk forcing and feedback. We talked more about forcing yesterday. We've heard about feedback here in this room. Doubled CO2 would add 4 watts to every square meter of the planet, 24/7, night and day, winter and summer, pole to pole, for the rest of your life. That's without the feedback. That's the forcing. Producing a decent standard of living for 3 billion extra people that are currently poor will not require doubling CO2, it will require quadrupling CO2 if we choose to do it with coal compared to pre-industrial. In the 20th century, we had a 30% increase in CO2. In the 21st century, we'll go to a 400% increase in CO2, not a 30% increase in CO2. You can argue about the sensitivity. You can argue about whether 30% increase produces a half a degree or a degree or whatever. Doesn't matter. That's the details that is not worth your time to argue. But if you believe that heat warms things up, a 400% difference is a big difference to you too. You should be extremely skeptical of anybody who claims to find 8 watts per square meter of negative feedback in the climate system. Why? Because you should have listened more carefully to Harrison Schmitt in the last session and to the talk that Nicholas Scafetta just gave, and know that a watt per square meter here or there, extended over any period of time, produces a lot of climate change. It has every time through the geologic record. If it weren't sensitive to watts, the climate would never have changed. If you think the climate has ever changed in the past, then you acknowledge that the climate can change. And if the climate can change because heat goes in, the climate will change when heat goes in, you know? You don't want to be on the other side of that argument. Now let's talk about something that you may not know that you may want to contest. And this is actually where my research comes in. I study the fate of the CO2. Where does the CO2 go? Think of the world as a big reservoir, a big bathtub in this case. There's 800 billion tons of carbon in the atmosphere today. Fossil fuel burning currently puts a little more than 8 billion tons in every year, and almost all of the talk in the newspaper is about this part of the problem, is about this 8 billion tons that goes in every year. But the warming actually comes from the 800 billion tons that's already up there. The heat that is emitted by the CO2 isn't emitted out of this faucet. The heat is emitted out of the water in the tub. And the more water you put in the tub, the more heat comes down out of the atmosphere and warms things up. Now, we currently are very, very lucky that only about half of this 8 billion tons that goes into the tub every year stays in the tub, because there's a couple of leaks in the bottom of the tub. Primarily, the ocean dissolves some CO2 by the exact same chemistry that makes beer fizzy, okay? It's carbonation. And land plants currently photosynthesize about 2 billion tons a year more than they die. Believe it or not, things are growing faster than they're dying around the world, and that's sucking CO2 out of the air to the tune of about a quarter of all the fossil fuel emissions. A wonderful, wonderful thing. Would that it would go on forever. Would that it would increase. That would be just ducky. So the global carbon cycle has air in it. It has, I've lost my pointer here. It has ocean in it, and it has land in it. And the humans are burning stuff and putting 4 billion tons, 8 billion tons a year in, but only 4 sticks. The land and the ocean exchange a lot of CO2 with the atmosphere. In fact, the exchanges in and out of the land and the ocean are enough. If it weren't for them being in balance, they would suck all the CO2 out of the atmosphere in about 6 years and everything would die. So we're awfully glad that they are in balance. Where's all the CO2 gone? About half of it, of the missing carbon, has gone into the oceans, both by dissolving and through biology. Let's talk about the land. I just said a minute ago, did you get that? Stuff is growing faster than it's dying. There's more and more biomass on the planet every year, and has been for most of my lifetime. Remarkable thing, amazing thing. How does that work? CO2 fertilization. The more CO2 the plants get, the faster they grow. More is better. It's like the gift that keeps on giving. This is a good thing. Nutrient fertilization. We're dumping a lot of Miracle Grow on our tomatoes and so forth, and things grow faster from that. Land use change. You've heard of tropical deforestation, but when I was a kid in Massachusetts, we would find these lovely stone walls out in the forest out there, and you wonder who the heck went to the trouble to build this beautiful wall out in the middle of the woods. Well, the reason that they put all that trouble into it, it didn't used to be woods. 150 years ago, there was no forest in New England. It was all farms, and as those trees have grown back, every molecule of wood in those forests used to be a molecule of CO2 in the air. The other thing is actually going on is response to the changing climate. As the Arctic and the boreal zone warm up, you got shrubby, woody plants growing in places that didn't used to be able to support them, and there's carbon going into those places. So this is all great. Half the CO2 from fossil fuel goes away. It's a wonderful thing that it does. If you think about it, though, once you're done sort of growing back the forests and putting forests in places there didn't used to be forests, you're done. That's as much carbon as you can fit on the land. I mean, there may come a day when I have to machete my way to my garage, through all the kudzu to be able to get through the plants that have grown, but you're not going to be able to grow rainforests in the Sahara. You're not going to be able to grow rainforests in Greenland. There's only so much carbon that you can fit in these reservoirs. What about the oceans? The oceans are really the big reservoir, and that's where we want the carbon to go. The trouble with the oceans, unfortunately, is that they're very strongly stratified. That's a techie scientific word, but what it really means is that the surface of the ocean is warm and buoyant. It floats. It literally floats like a raft. There's 100 meters of warm water that sits on top of 3,000 meters of cold water, and that cold water is heavy and dense, and it sits at the bottom, and it's inky and black, and no matter where you go in the world, if you go to Tahiti with the palm trees and the nice beaches, if you were to dive down deep enough, you would find icy black cold water down there, which is not touching the atmosphere and can't react with the atmosphere except as it mixes back up. That water doesn't know we're here yet. That water hasn't seen the surface in 1,000 years, and it doesn't have any anthropogenic chemistry in it. It's very, very stable. Because that water is cold, it sits at the bottom. It's very hard for that water to mix back up to the top, touch the atmosphere, take the CO2. It takes about 1,000 years to turn this over. We know this because we've been there. People have gone out across the world oceans and taken samples to the bottom with these interesting rosette bottles. And each one of these lines is composed of a bunch of little dots you probably can't see, but each dot is a place where water has been taken all the way to the bottom of the ocean and the chemistry has been done. So we've got 3D chemistry of the world ocean. And these are some samples of that data. And it shows the fossil CO2 in the world oceans. And you can see that it's only penetrating into the very top water, the water that's actually warm and buoyant and floats to the top. It takes a long time. It takes 1,000 years for that deep water to circulate back up to the surface and touch the atmosphere and take the CO2 out. So get that in through your heads. It takes 1,000 years to turn the ocean over once. So the mixing time of the ocean is about as long as from now back to William the Conqueror. So this means that we have a long tail on the CO2 that China and India will put into the atmosphere in our lifetimes. There is a myth. There is a myth in the media, in the newspapers, that almost everybody believes, which is that when we reduce or stop burning fossil fuel, the CO2 will go away and things will go back to normal. And I'm sorry to tell you, but the physics just doesn't agree with that. The trouble is that the CO2 hasn't risen very much since the Industrial Revolution, just about 30%. But when China and India grow their economies, as they must, to deliver a decent standard of living to their people, the CO2 is going to increase a lot, way, way more than it did in the last century. And that CO2 is going to stay in the air for thousands of years because it only takes multiple mixings of the ocean to take that CO2 back out. So we're going to be stuck with this for a long, long, long time. So let's come back to my simple facts again. 1, CO2 emits heat. 2, CO2 stays around for thousands of years. 3, extra heat warms things up. 4, Earth's climate has always changed because of extra heat. There's really no reason to believe that this time will be different, that this time there will be no climate change with all those extra watts. The physics basically doesn't care what you believe. People will wind up adapting to this. They always have, they always will. But if you don't help us to figure out how to adapt, we're going to wind up adapting in ways that are unacceptable to you. In fact, here are some examples of bad or ineffective policy that might be enacted to deal with this problem. Light bulbs. This is not going to cut it, folks. I'm sorry, but changing your light bulbs is not going to take care of a problem that's going to last for thousands of years. State or national level penalties for things. The government choosing winners and losers. fiddling with the details at the edges of this problem is not going to cut it. It's not going to solve anything, and it's going to harm people. Making people poorer is not going to help, okay? If this is what you want, keep doing what you're doing, because this is what's happening. What we need instead are effective solutions. We need solutions that will provide a decent quality of life for billions of people on this planet. Those people are going to need energy. They're going to need energy to provide for wealth. They're going to need energy to provide a decent amount of well-being. Only a free market can bring this kind of change about. We are not going to get this kind of change from interventionist government taking winners and losers. Who's going to advocate for these effective solutions? Do you think Greenpeace is going to advocate for this? Is that what you're waiting for? Evidently. If free market advocates shirk their responsibility, others will dictate the policy. Is that really what you want? When will you stand up and offer solutions to these problems? Are you cowards? What I said to you just now, to recap, in case you missed it. Everyone in this room understands how climate works well enough. It is not worth your time to argue about the third decimal point. You are wasting your time. Climate is going to change a lot in the next few decades, and policy will, in fact, be enacted to deal with perceived needs. The political right has been absent without leave in proposing solutions to these problems, and the world needs you to be engaged. Thank you.